My name is Paige Gerhart, and the research question that I did was, do high school girls like sparkling water more than high school guys? First, I will test an appropriate hypothesis and state my null and alternative hypothesis. Then I will state my conclusion. Next, I will create a 95% confidence interval for the difference in the proportion of female high school students and male high school students who like sparkling water, to conclude that the results show that more girls like sparkling water than guys. I chose this question because I love sparkling water and know a lot of my girlfriends do as well. However, a majority of my guy friends prefer soda, so I'm curious if in general more high school girls at my school enjoy the taste of sparkling water. I had wanted to do this for a while, so I was excited as I really did not have a clue how the results would end up. I performed a survey of 50 high school girls and 50 high school boys to find out if there was enough evidence to conclude that one gender likes sparkling water more than the other. The variable is gender. My hypothesis is that girls like sparkling water more than guys. I hope you enjoy my project. Now let's get started. How I performed my survey. I performed a survey at my high school. As I mentioned before, I'm in leadership and therefore have access to a master list of everyone in the school. I first separated the boys and girls in my school into two data groups. Then I correlated every first name to a number, starting with 0001 for the first girl in the alphabet, 0002 for the second girl in the alphabet, and so on, until every girl in my school had been numbered. Then I did the same thing for the boys. Next, I used a random number generator to generate 50 random numbers that I used for both the girls' and guys' random numbers. Next, I went back and looked at what the girls and what boys correlated to the randomly chosen numbers, which was my sample of respondents. I then found these 50 girls and 50 boys during third and fourth period and asked them, do you like or dislike sparkling water? In order to reduce bias, I made sure to not tell them my opinion so that they wouldn't feel obligated to side with my hypothesis. In addition, I was originally going to ask them, do you like sparkling water? However, I felt that that could create some bias, so I changed it to, do you like or dislike sparkling water? I also reduced bias by using randomization to ensure I did not know who I was going to ask. As I mentioned in my Unit 6 project proposal, I brought around a chart with me to record my data. The chart for both the girls' results and guys' results are shown next. My data table results. The first data table shows the survey results for the high school females who disliked and liked sparkling water. A yellow box in the like sparkling water means they said they liked it, while a yellow box in the dislike sparkling water means that they said they did not like sparkling water. The second data table is the same as the first. However, this time it's the survey results for the high school males who liked and disliked sparkling water. These were the charts that I carried around when I asked people, which made it easier to collect my data. As you can tell from the charts, out of the 50 girls I surveyed, 30 of them said they liked sparkling water, while only 20 of them said they did not. However, out of the 50 boys from my school that I surveyed, only 17 of them said they liked sparkling water, while 33 said they did not like sparkling water. My worries and overall goal. From the start, I was worried that some people could possibly think that unflavored sparkling water could somehow taste different. I was also worried that people might not want to answer my survey, which would make me go back to the random number generator and find a new number, and then I would have to find a new girl and guy that correlated to that number. It would be a mess. My goal throughout my survey was to establish a statement that either girls or boys like sparkling water more than the other gender. Now it's time to talk about the tests I ran to reach my overall conclusion. I performed a 1 proportion z-test for both genders to find if we should expect either gender to have a percentage different than 50% for those who prefer sparkling water. This test will be used as a guideline, but will not be used the most. This test isn't a very large factor, but can help make a conclusion overall. As you can see, for both tests, the hypothesis is the same. The null hypothesis is that the proportion equals 0.5, whereas the alternative hypothesis is that the proportion is different than 0.5. The conditions are all met. The independence assumption is that all the data is independent of each other and one answer doesn't affect the next. The randomization condition is that I ensured randomization by using a random number generator. The 10% condition was met because the 50 girls who I surveyed and the 50 guys who I surveyed are both less than 10% of the entire population of girls and guys at my school. The success and failure condition is met because when you multiply n times p, you get 25, and when you multiply n times q, you get 25. Since there are at least 10 successes and 10 failures, that condition is met. Since all the conditions we talked about are met, we can go ahead with the one sample z-test. This is the data for the girls. Here is my work on how I got my z-value and my p-value. My z-value equals 1.414, whereas my p-value, which I found by using technology, is 0.1573. This is a graph of the p-value. Since the p-value is greater than 0.05, we fail to reject the null hypothesis. There is not enough evidence to conclude otherwise. Therefore, we expect 50% of girls to like sparkling water and 50% of girls to dislike sparkling water. Now let's look at the boys' results. This is my work for how I got my z and p values for the boys. My z-value is negative 2.263, and my p-value, which I found using technology, is 0.0237. This is a graph of the p-value. Since the p-value is less than 0.05, we can reject the null hypothesis. There is enough evidence to state that there is a different percentage of high school boys, other than 50%, who like sparkling water. Now we know that boys have a different percentage of those who like sparkling water compared to girls. However, we still need to figure out if they prefer sparkling water more or less than girls. Next, I performed 90% confidence intervals for both genders. For both the girls and boys, all the conditions are the same as from the first test. Since all the conditions are satisfied, we can use a 1 proportion z interval to estimate the proportion of girls who drink sparkling water in a 90% confidence interval, as well as the proportion of guys who drink sparkling water in a 90% confidence interval. Here is my work for the girls' 90% confidence interval. As you can see, we are 90% confident that between 48.57% and 71.43% of high school girls like sparkling water. Now let's look at the boys' 90% confidence interval. As you can see, we are 90% confident that between 22.95% and 45.05% of high school boys like sparkling water. The confidence interval shows that so far, we can conclude that more girls like sparkling water than boys in high school. So far, the two tests have helped to show that girls like sparkling water more than guys. However, we still need to do a two-sample test. The third test is a two-proportion z-test. Let's first start by talking about the hypothesis. P1 equals the proportion of high school girls who like sparkling water, whereas P2 equals the proportion of high school guys who like sparkling water. The null hypothesis is P1 subtract P2 equals 0, whereas the alternative hypothesis is P1 subtract P2 is greater than 0. Now let's check to make sure the conditions are met. The independent group assumption. The groups are independent of each other, so this condition is met. Independence assumption. Within each group, the data is independent, so this condition is met as well. The randomization condition is met because I used a random number generator to ensure randomization. The 10% condition is also met because the sample is combined to equal less than 10% of the entire population of my school. Finally, the success/failure condition. Each group has at least 10 successes and 10 failures as shown in the first test, so this condition is also met. Since all the conditions are met, we can continue by using a two-proportion z-test. Now let's look at our data. We know that P1 equals 0.6 because 30 out of the 50 girls like sparkling water, whereas P2 equals 0.34 because 17 out of the 50 boys like sparkling water. As you can see from the test, the z-score equals 2.605, whereas the p-score equals 0.0046. This is a graph of the p-value. Since p is less than 0.05, there is enough evidence to reject the null hypothesis. This means that there is a difference in proportions and that the data from P1, which is the girls who like sparkling water, is greater than P2, which is the guys who like sparkling water. There is significant evidence that girls like sparkling water more than guys at my school. Now finally, let's look at a 95% confidence interval for a two-proportion z-test. Now that we can conclude that there is evidence that girls at my high school like sparkling water more than guys, I used a 95% confidence interval for a two-proportion z-test to see what percent of girls like sparkling water more than guys. We know from the third test that all the conditions are met. Since all the conditions are met, we can continue to do a 95% confidence interval for a two-proportion z-test. By looking at the data, you can see the results for the 95% confidence interval. 95% confident means that 95% of all random samples produced in the interval that contain the true difference. We are 95% confident that the proportion of girls who like sparkling water is about 7.1% to 44.9% greater than for boys who like sparkling water at my school. Now it's time to make a conclusion. Now that I have fully looked through all the data, it was time to make a conclusion. Since I did 4 different tests, I looked at each one individually. The first test was the one-proportion z-test, which showed that there was not enough evidence to conclude that there is a different percentage other than 50% of girls who like sparkling water. However, for the boys' test, there was enough evidence to state that there is a different percentage other than 50% of high school boys who like sparkling water. Now we know that the boys have a different percentage of those who like sparkling water compared to the girls. However, I still needed to figure out if they prefer it more or less than the 50% of girls who like sparkling water. Therefore, the next test I performed was a 90% confidence interval for both genders. The conclusions I came to were I was 90% confident that between 48.57% and 71.43% of high school girls like sparkling water. Whereas, for the boys, I was 90% confident that between 22.59% and 45.05% of high school boys like sparkling water. Overall, the 2 tests shows that so far we can conclude that more girls like sparkling water than boys in high school, but we still need to do a 2-sample test. The third test I did was a two-proportion z-test. I received a very low p-score of 0.0046, so I was able to reject the null hypothesis. This means that there is a difference in proportions and that the data from P1, which is the girls who like sparkling water, is greater than P2, which is the guys who like sparkling water. There is significant evidence that girls like sparkling water more than guys at my school. Finally, the last test I did was to see the percent of girls who like sparkling water more than guys. I used a 95% confidence interval for a two-proportion z-test. From the results, I concluded that I was 95% confident that the proportion of girls who like sparkling water is about 7.1% to 44.9% greater than for boys who like sparkling water at my school. From all the data and research, I can conclude that according to my data and tests, high school girls at my school like sparkling water more than high school guys at my school. I realized that my hypothesis, high school girls like sparkling water more than high school guys, was in fact correct as well. Now that I've finished my conclusion, it's time to reflect. First, let's look at how I could improve my data. If I were to do this project again, I would survey the entire school, because the larger the population, the less errors there would be. In addition, I would bring all my test subjects the same brand of unflavored sparkling water, so there was no confusion on the brand whatsoever. Now let's look at some obstacles and challenges I faced. I ended up having a few of the same challenges that I did as last project, even though I changed a few of my strategies. Here they are. The first obstacle I faced was that I had never talked to some of these people before in my life, so when I went to go talk to them, they were very confused. However, this time, I got more to the point and simply explained the reason why I needed their help. I then asked for their opinion and moved on to the next person, so they wouldn't think that I was lingering for too long or acting creepy. The second obstacle I faced was it was hard to find all the people I had randomly selected, since I only knew their names from the book in leadership. I ended up having to go to the office multiple times to look up photos of some of the kids as well as their classes. I used my strategy from last time of going in during fourth period classes and asking them. However, it was hard when they were gone from that class. Thirdly, one of the girls who was answering my survey asked me, "Well, what brand of sparkling water are you talking about? Because I don't like any of them except for San Pellegrino sparkling water." I was confused as I thought all plain sparkling waters had no added flavor. I ended up bringing her a sparkling water the next day and asking her if she liked it. Her answer was yes, so that problem was averted. Now let's look at some possible extensions of my research. To extend my research even more, I would survey people from different schools, because the results could be different in different locations. I could also choose a flavor of sparkling water and see if guys liked that flavor better than plain sparkling water, and how the guys' results would compare to the girls' results who liked that flavor of sparkling water. You have now reached the end of my video. Congrats, you made it through a very long video. Thank you for watching, and thank you for an amazing year. I'm so glad I took this online AP Stats class.